Greetings, class. This is the lecture for Monday, August 21st, 2017 for basic math. As an update, I was working on the materials over the weekend and I got locked out Saturday night. So that means that I'm still not able to post things online. So you just have to be patient until it's there. Just kind of keep checking. But I just don't have the full access like I thought I had. So still kind of straighten all that out. So in the meantime, we'll just kind of move forward and we'll play it by ear. We just kind of have to keep going for where we are. So for today's lecture, one of the students brought it to my attention that what I spoke on last time, the title didn't match what was in the syllabus, and I looked at it. So this is the lecture that kind of coincides with what's in the syllabus. So we're going to do this. So if you missed last week, that's okay. We'll be kind of going through everything in detail starting now. So we're actually starting from the beginning now. So for chapter 1, we have section 1.1, linear equations in one variables. And we want to decide whether each of the following is an equation or an expression. So I think last week we said that equations tend to have an equal sign and expressions tend not to have an equal sign. So following that rule of thumb, that means A would be an equation, B would be an expression, and C would be an expression. So then the next logical idea or the next logical flow was, so for equations, we can solve equations like in part A. If we were to solve for x, we would divide both sides by 9 and we get x equals 10 over 9. So because we started with an equal sign, which is an equation, then we can solve for x. Expressions, we can't solve for it. We can't get it down to like x equals something or y equals something or whatever. But we can simplify expressions. So equations we can solve and we'll get an answer like x equals something or whatever the variable is equals something. But expressions we can only simplify. Okay, so that can take on many different forms, but generally we don't get to a solution like x equals some number or whatever. So really no work to show there. We just ended up with these results. Okay, so a linear equation in one variable can be written in the form ax plus b equal to c, where a, b, and c are real numbers with a not equal to 0. Okay. So a, b, and c are just real numbers. This is a linear equation in one variable. We have a lot of things that come out of this, and we'll kind of take them as they come. So now with this example 2, we already have the solutions, which is fine. But let's see how we arrive to those conclusions. So in example 2, part A, it says solve and check. So notice that we're starting with an equal sign, which indicates that it is an equation. So we should get it down, be able to get it down to P equals something or whatever. So the first thing we want to do is combine like terms. So we want to combine like terms. Okay. So then the question is, what are the like terms? Well, on the left, for instance, the like terms on the left side of the equal sign is a 3p plus 2p. We add those together to give us 5p. The 1 comes down, the equal sign comes down, and the negative 24 comes down. So then we can use something called the additive property of equality. Okay, and we can add and subtract the same thing from either side of the equal sign and preserve equality. So in this case, we'll subtract 1 from both sides. Okay. And you'll see when we do this, so now 1 plus a negative 1, they cancel, they go to 0. On the left, we're left with 5p. A negative 24 plus a negative 1 is going to be negative 25. So just like we have the additive property of equality, we have the multiplicative property of equality. We can multiply or divide the same non-zero number to the left and right side of the equal sign and preserve equality. So in this case, we would divide by 5 and divide by 5. The 5s would cancel on the left. And negative 25 divided by 5 is negative 5. Okay. And so you can check that. You can check by you replace p with -5 in the original, and you should finish with the true statement. I'm going to leave that as an exercise and move on to the next one. So the same thing with the first step in part B is we want to combine like terms. So combine like terms. So on the left, there's nothing that combines with the 3p for right now, so that stays as is. On the right, our like terms, we have a 2p and a 4p, and they add up to 6p. So we'll have 6p plus 5, and then addition property of equality, so we're going to subtract 6p and subtract 6p. Or you can say you're adding -6p to both sides. On the right, they're going to cancel. 3 plus a -6 is a -3p. It's going to be 5, and then divide both sides by -3. And we finish with this result. P equals a -5/3. So right, like we said, we have the addition property of equality for all real numbers a, b, and c. The equations a equal b and a plus c equal to b plus c are equivalent. In words, the same number may be added to each side of the equation without changing the solution set. So then we also have the multiplication property of equality, which we've used. We've used both of these already. For all real numbers a and b, and for a c not equal to 0, the equations a equal to b and a times c equal to b times c are equivalent. In other words, each side of an equation may be multiplied by the same non-zero number without changing the solution set. Okay. So when we want to solve a linear equation in one variable, this is a general guideline that you can follow. So step one, we want to clear any fractions or decimals. So we clear fractions by multiplying the left and the right side of the equal sign by the least common denominator, the LCD. We eliminate decimals by multiplying the left and the right side of the equal sign by the appropriate power of 10. Say the highest decimal, the longest decimal space, it goes out to, say, 2 decimal places, then we multiply the left and the right side of the equal sign by 100. So that takes a little bit of practice, but that's the general rule of thumb. So then once we've gotten rid of fractions and decimals, then we want to simplify each side separately. So that's where we're combining the like terms on the left and the right. And then next we want to isolate the variable term, so we use the addition property of equality and the multiplication property of equality. We want to get the variable on one side by itself and then everything else on the right. Okay, and then finally the fifth step is to check. So from then, after doing those steps, we should be able to get down to a solution, and you just check the answer in the original question, which is what we pretty much did these steps in those first couple of examples that we did.